Hello everyone, and welcome to Earth Archives. Today we're talking about a super special planet, Uranus. It's not just a dreamy blue-green ice giant, but also one of the most mysterious planets in the solar system because of its bizarre way of spinning. Did you know? Uranus actually spins lying down. What does that even mean?
That's such an interesting question. Most planets, like Earth, have a rotational tilt of about 23.5 degrees. Mars is similar, and that's what gives us clear seasonal changes. But Uranus? It doesn't follow the usual rules at all. Its axis is tilted at an extreme angle of 97.7 degrees, which basically means it's lying on its side compared to its orbit. Imagine a giant ball rolling sideways through space. That's Uranus. This strange orientation makes it one of the quirkiest planets in the solar system. Because of this extreme tilt, Uranus experiences some wild seasonal changes. As it travels around the Sun, its poles take turns facing the Sun directly. That means one pole can be in constant sunlight for over 20 years, while the other is plunged into darkness for just as long. This unusual behavior makes Uranus's climate completely different from any other planet, raising lots of questions about its internal structure and how it formed. As for why Uranus is lying on its side, the leading theory is that during its early formation, it was hit by a massive object, a colossal collision that almost knocked it over completely and drastically altered its rotational axis. This unique tilt not only affects its seasons, but also creates a weirdly complex magnetic field. Its magnetic axis is significantly offset from its rotational axis, adding yet another layer of mystery to this fascinating planet.
Wow, so it doesn't spin upright like a good planet, but more like it's rolling around. Does that make its seasons really weird?
Exactly. Uranus's rotational axis is practically flipped, which creates extreme and surreal lighting conditions at its poles. As Uranus orbits the Sun, its poles take turns pointing directly at it. That means once a pole enters daytime, it stays in sunlight for about 42 years straight, and when it shifts to nighttime, it plunges into 42 years of darkness. This incredibly long day-night cycle makes Uranus the most dramatically lit planet in the solar system. Just imagine, if you lived at Uranus's North Pole, you could spend your entire life in either a sunrise or sunset phase. This extreme light and dark contrast doesn't just affect the scenery. It deeply influences the planet's climate and atmospheric circulation. 42 years of constant sunlight could lead to significant temperature and atmospheric shifts, while 42 years of darkness means the polar regions experience extended periods of deep cold and shadow. That kind of environment is completely unlike anything we have on Earth. These lighting conditions are all due to Uranus's nearly horizontal rotational axis, making it the most sideways planet in the solar system. This unique tilt creates a strange seasonal pattern during its orbit, one that's entirely different from any other planet, and adds complexity to both its magnetic field and atmospheric dynamics.
Oh my gosh, that's basically half a century spent in darkness. People living there wouldn't even need sunglasses, right?
Uranus is truly one of the most extreme and mysterious planets in the solar system. Because it rotates almost completely on its side, its poles experience 42 years of continuous daylight, followed by 42 years of night. This kind of extreme day-night cycle creates intense and complex climate patterns. Just imagine a region exposed to sunlight for decades, only to be plunged into darkness for just as long. The atmospheric and climate effects of such a cycle are unlike anything we see on other planets. Even more astonishing is that Uranus is also the coldest planet in the solar system. Its temperature can drop as low as minus 224 degrees Celsius. That's about minus 371 degrees Fahrenheit. Hundreds of times colder than your household freezer. That's why Uranus is classified as an ice giant, made primarily of icy substances like water, ammonia, and methane. These frozen materials, under such extreme temperatures, give Uranus its signature bluish-green color. The combination of extreme day-night alternation and ultra-low temperatures shapes Uranus's unique climate. Long periods of sunlight allow energy to build up in the atmosphere, but then it suddenly enters a deep freeze during the long night. This dramatic contrast fuels powerful weather patterns, with wild storms and incredibly fast winds that sweep across the entire planet.
Wow! So it's colder than Neptune? But isn't Neptune farther from the Sun?
Uranus and Neptune, the outermost ice giant siblings in the solar system, may look similar on the outside, but their internal stories are completely different. In theory, the farther a planet is from the Sun, the colder it should be. But surprisingly, Neptune is actually a bit warmer than Uranus. The secret behind this lies in Neptune's strong internal heat source, which continuously releases heat from its core, like a glowing ember that keeps the entire planet at a steady temperature. In contrast, Uranus is like a thermos that has gone cold, barely releasing any internal heat, which makes it one of the coldest planets in the solar system. This unusual cooling phenomenon has puzzled scientists for a long time, until they proposed a striking hypothesis. Uranus once experienced a massive cosmic collision. This ancient cosmic crash not only altered Uranus's rotational axis, causing it to lie nearly sideways on its orbital plane, but also severely damaged its internal structure. As a result of this internal disruption, heat is trapped inside and cannot easily escape to the outer layers, making Uranus like a frozen refrigerator that continuously radiates an icy chill.
So Uranus is the coolest character in the solar system? No wonder it looks blue-green and chilly. But where does its blue-green color come from?
Neptune's stunning blue-green appearance actually hides a natural color magic. This mysterious color mainly comes from the abundant methane molecules in its atmosphere. Methane isn't just a major component of natural gas. It also acts like a light filter in Neptune's atmosphere. When sunlight hits Neptune, methane selectively absorbs the red wavelengths of light and reflects back the blue and green ones. This filtering of light is why, through telescopes, we see Neptune as a giant blue-green orb shimmering with icy brilliance. This unique blue-green color not only makes Neptune stand out in the solar system, but also reflects its extremely cold and chemically rich environment. Methane is present in high concentrations in Neptune's atmosphere, mixed with hydrogen and helium, creating the distinct visual signature of this ice giant. From Earth, Neptune's color resembles an icy blue gem, captivating and mysterious, inviting us to explore the secrets behind it. This color magic is also a key clue for astronomers to understand the planet's composition and atmospheric properties. The methane absorption spectrum helps us learn not only about Neptune's atmospheric makeup, but also about its cold climate and chemical processes. As exploration technology advances, we may soon uncover even more secrets about this blue-green giant and reveal deeper mysteries about the evolution of ice giants and the formation of our solar system.
I see, so it's basically a methane filter planet. But besides its beautiful color, does its atmosphere have any other amazing features?
Uranus's incredible wind speeds are absolutely jaw-dropping. On this icy giant surface, winds can reach up to 900 kilometers per hour, faster than many fighter jets, like raging storms tearing through space. These extreme winds not only showcase the dynamic nature of Uranus's atmosphere, but also intrigue scientists who study its weather patterns. What's even more fascinating is that Uranus's atmospheric motions are full of contradictions and oddities. Near the equator, the winds blow opposite to the planet's rotation, but as you move toward the poles, the wind direction reverses and follows the rotation. This unique difference in wind direction gives Uranus a kind of split personality, with airflow in different regions moving to completely different rhythms and directions, like a chaotic dance within its atmosphere. This complex and intense atmospheric behavior is likely related to Uranus's unusual tilted axis. Since Uranus lies almost on its side relative to its orbit, sunlight distribution across its surface is extremely uneven, which affects wind speeds and directions, creating these astonishing weather phenomena. Additionally, Uranus's internal structure and heat output probably play a role in driving these high-speed winds, making the planet's atmospheric activity highly variable and difficult to predict.
Wow! That sounds 100 times crazier than a typhoon on Earth, right?
Uranus's magnetic field is truly one of the universe's strangest phenomena. Most planets have magnetic fields that align fairly closely with their rotational axes, creating a stable and symmetrical magnetic structure. But Uranus doesn't follow the usual rules. Its magnetic axis is tilted nearly 60 degrees away from its rotation axis. This means the magnetic North Pole and the geographic North Pole are in very different places, making the entire magnetic field look like a crooked battery. Not only is the angle unusual, but the magnetic center is also offset by thousands of kilometers from the planet's center. Such a tilt is extremely rare among planets in the solar system. This highly asymmetric magnetic field causes Uranus's magnetic strength and direction to fluctuate constantly, sometimes strong, sometimes weak, almost like it has its own mood swings, which makes it very challenging for scientists to study. It's less like a simple magnetic field and more like a complex, ever-changing maze, placing Uranus at the forefront of magnetic field research. Astronomers speculate that this unusual magnetic structure is related to Uranus's unique internal makeup, especially the position and shape of its electrically conductive liquid layer inside, which creates such a crooked and unstable magnetic field.
Ha ha ha, this planet is basically the universe's weirdo. Even its magnetic field doesn't play by the rules. Besides the strange magnetic field and rotation, does it have rings? I know Saturn has those stunning rings. Does Uranus have them too?
Uranus's ring system is quite low-key. Compared to Saturn's spectacular, shining rings, Uranus's rings are the ultimate in subtlety. There are 13 rings around Uranus, but they're very thin and dark, almost black in color, with extremely low reflectivity, like pieces of cosmic charcoal, making them invisible to the naked eye. Because of their hidden nature, Uranus's rings weren't discovered until 1977. What's even more surprising is that these 13 rings weren't spotted directly through telescopes. Instead, astronomers discovered them accidentally through an event called a stellar occultation. At that time, scientists noticed the light from a star suddenly dimmed briefly as Uranus passed in front of it. After careful analysis, they realized the dimming wasn't just caused by Uranus blocking the star, but by the starlight passing through the planet's thin rings, causing multiple dips in brightness. This discovery not only confirmed Uranus's rings, but also opened the door to more detailed research on the ice giant's ring system.
Wow, so Uranus is like it's wearing a black invisible ring. That's so cool.
Although Uranus's ring system is low-key, it's guarded by a group of shepherd moons that silently keep these dark cosmic rings stable, which is truly amazing. These small moons act like loyal shepherd dogs, using their gravity to guide the tiny particles in the rings, preventing them from drifting away and ensuring the rings remain clear and compact. Thanks to these shepherd moons, Uranus's rings can peacefully exist in the vastness of space without being scattered by gravitational disturbances. Although these moons are small in size, they play a crucial role in astronomer studies. They use subtle gravitational forces to keep the ice and rock particles in the rings stable in fixed orbits, like guarding a mischievous flock of sheep to prevent them from running wild or scattering everywhere. This natural gravity management system not only maintains the beautiful shape of Uranus's rings, but also allows scientists to closely observe the composition and changes of the rings. Interestingly, this shepherd moon phenomenon isn't unique to Uranus. Other ringed planets, like Saturn, also have similar small moons that maintain the stability of their rings through gravitational effects. But because Uranus's rings are so faint and thin, the role of these shepherd moons is especially important, making them the invisible guardians of the ring system structure.
Oh, so there are shepherd dogs helping keep order. Are Uranus's moons special too?
Uranus's moon system is very unique, with a total of 27 known moons, and there's actually a romantic cultural story behind their names. Most of these moons are named after characters from the classic works of Shakespeare and Alexander Pope, cleverly combining literature with astronomy and adding a poetic touch to this icy giant. For example, Titania and Oberon are the fairy queen and king from Shakespeare's play A Midsummer Night's Dream. These names are not only mysterious, but also evoke images of that magical and beautiful fairyland. Beside Titania and Oberon, there are also Ariel and Miranda, both named after characters from Shakespeare's other famous play The Tempest. These moon names are like cultural treasures in the astronomy world, allowing us to feel the romantic atmosphere of literature while exploring the cold planet Uranus. Why this special naming convention? It relates to the cultural background of astronomers in the 19th century, when Uranus's moons were first discovered. At that time, Western literature, especially Shakespeare's works, had a profound influence in academic circles. So these elegant and imaginative names became the preferred choice for naming the moons. This successfully gave Uranus's moon system a unique artistic aura.
Wow, no wonder Uranus is called the most literary planet. Shakespeare fans must absolutely love it. So, do these moons have any special features?
Among Uranus's moons, Miranda is definitely the most mysterious and eye-catching one. Its surface is covered with all kinds of strange cracks and cliffs, as if a puzzle was broken apart and then pieced back together, showing a dramatically unique geological landscape. This unusual appearance has sparked scientists' curiosity and led to many astonishing theories. Based on observations and studies, scientists believe Miranda went through a massive impact event that shattered it into multiple pieces. Over a long period, these fragments reassembled, creating the patchwork-like surface we see today. This kind of process is rare in the universe, making Miranda a special case in the eyes of astronomers, symbolizing the powerful forces of cosmic collisions and reshaping. The cracks on Miranda's surface are several kilometers deep, and some cliffs soar over 20 kilometers high, like gigantic canyons in space. These intense geological features not only reflect its turbulent history, but also make it stand out among Uranus's many moons. These cliffs and fissures are likely the result of early internal activity and geological shifts, revealing the complexity of Miranda's internal structure.
Wow, that sounds like a Frankenstein moon.
Among Uranus's moons, Titania and Oberon are undoubtedly the heavyweight stars, each with diameters over 1,500 kilometers, large enough to rival many small planets. These two moons not only impress with their size, but also boast rich and diverse geological features, making them stand out in the Uranian system. Titania's surface is dotted with numerous canyons and cliffs, evidence of intense geological activity in the past, while Oberon bears many impact craters, like a scar diary, recording its ancient history page by page. In contrast, Ariel is like the icy masterpiece of Uranus's moons. Its surface is covered with vast glacier terrains, with clearly defined glacial patterns that look like nature's frost-carved artwork. These glaciers not only showcase Ariel's spectacular surface, but also hint at possibly active geological processes beneath. The movement and changes of these glaciers make Ariel more than just a cold moon. It's like a lively ice crystal artist. The diversity and unique landscapes of these moons inspire astronomers with endless imagination. Each moon has its own story and secrets, from Titania and Oberon's majestic mountains to Ariel's glacial textures, all telling the incredible natural wonders of the cosmos.
So the whole Uranus system is a combination of ice and poetry. No wonder it's called the ice giant.
Uranus takes a whopping 84 years to complete one orbit around the Sun, which means one Uranian year is way longer than a human lifetime. In other words, If you were born on Uranus, you might have to wait until you're old and gray to celebrate your very first birthday. This timescale makes Uranus the ultimate slow-living planet in the solar system. Compared to Earth's 365-day year, it's like an entirely different rhythm of life. Uranus orbits very far from the Sun, about 2.8 billion kilometers on average, which explains its lengthy orbital period. This long year brings unique climate and lighting changes, especially with its extreme axial tilt, causing the poles to experience 42 years of continuous daylight, followed by 42 years of night. Just the fact that one day equals 2 years on Uranus is astonishing. You can imagine that people living there might only throw birthday parties a few times in their lives, but each one would be a grand celebration, a true highlight of their existence. This lengthy orbit also makes Uranus an important target for studying the solar system's evolution. Astronomers analyze its orbit and motion to uncover mysteries about the outer regions of the solar system. Uranus's slow journey is not just a piece of astronomical data, but a witness to the flow of cosmic time.
Haha, so I can stay 18 forever. Because I'd never make it to my next birthday.
Uranus, that distant and mysterious ice giant, offers us not only its stunning blue-green glow, but also a kind of unimaginable romance with time. It takes a full 84 years to orbit the Sun, meaning one Uranian year is almost the length of a human lifetime. This incredibly slow pace makes Uranus one of the most unique worlds in our solar system. Imagine living on Uranus. Going from birth to your first birthday could take decades, or even your entire life. This long wait makes birthdays incredibly precious, turning time itself into a rare luxury. Uranus's extreme axial tilt causes its poles to experience 42 years of continuous daylight, followed by 42 years of night, making the whole planet seem like it's breathing slowly, stretching the flow of time into a long, poetic rhythm.
It sounds like Uranus, though cold and icy, is full of literary charm and mysterious scientific puzzles. It's really fascinating.
Uranus, this distant and mysterious ice giant, remains one of the least explored planets in the solar system. Since Voyager 2's brief flyby in 1986, our understanding of it has still been very limited. The precious data sent back then gave scientists a preliminary understanding of Uranus's unique tilted axis, blue-green atmosphere, and icy environment. But that's far from enough. Now, with advances in technology and space exploration capabilities, scientists are eagerly anticipating sending a new generation of probes to Uranus. This will be a brand new adventure, capable of uncovering many more of the planet's unsolved mysteries. Whether it's Uranus's extreme climate, its twisted magnetic field, or its hidden ring system and numerous moons, future missions hold the promise of revolutionary discoveries. Especially intriguing are Uranus's nearly horizontal axis, the 42-year-long polar day and night, and the secret of its cold interior that releases little heat, all waiting for scientists to unravel. New probes will be able to monitor its wind speeds, magnetic field changes, and even investigate the deep atmospheric composition in much greater detail, tasks that Voyager 2 simply couldn't accomplish.
Wow, I can't wait to see the Uranus Unlock project in action.
Yeah. Hopefully after today's sharing, everyone will have a greater appreciation for this cosmic oddball. If you think Uranus is as cool as we do, don't forget to like, subscribe, hit the notification bell, and leave a comment telling us which feature of Uranus surprised you the most.
That's right. Next time, we'll take you to explore even more mysterious planets, so stay tuned.